be solving the systems of equations by a different method. We're going to use row transformations. Okay? So something that you're probably not too familiar with is something called a matrix. And we'll do more with matrices later in another class period, but we're just going to kind of set up a matrix and we're going to use row transformations to solve the systems. Okay? So a matrix is basically just, it's a rectangular array of numbers enclosed by brackets. Okay, so for example, right here, we can take this and we're going to make this into a matrix. So we're going to use the coefficients in front. So it's a 1x and 3y and 2z equals 1. And then 2x, 1y, negative 1z equals 2. 1x, 1y, 1z equals 2. Okay, and a matrix is defined, we say it's a what by what matrix, okay, and we say the rows by the columns. So the rows, there are 3 different rows here. 1, 2, 3, right? 1, 2, 3 rows. So this is a 3 by, and columns, 1, 2, 3, 4. This is a 3 by 4 matrix is how we would define it. And we can call this matrix A or matrix B or whatever. Okay. The augmented matrix is basically we just do this. You put the coefficients here, and then a little line, and then what they're equal to. It just kind of separates the variables from what our constant, what it's equal to. Okay. So we have our matrix and our augmented matrix. Now, what we're going to do today is we want to transform these rows. Okay. So looking at each of these individual rows, we can do these things. Okay, these are all legal things to do. Any 2 rows can be interchanged. Okay, and if you think about solving these, if I take this row and this row, right, and I exchange those 2, that's fine, right? It doesn't matter if this one's first or that one's second or whatever. Okay. We can also, all elements row may be multiplied by a real number. So if you think about solving these equations, it's okay if I take 2 and I multiply every number by 2. Okay, so we can do that as well. Also, any row may be changed by adding it to its elements of a multiple of a corresponding row. So if I take like 2 times all of this and I add it to this, I can get something else, right? We've done that in the past too when we solved the equations, right? So when we used elimination, we've multiplied by something and then added some 2 things together to get a resulting matrix. So we can do those same resulting equations. We can do the same thing with matrices here too as well. Okay. So right here, this is what we want to start with. This is our starting equations. We just want to identify how do we get from this step to this step. Okay. So looking at this one and looking at this one, how are they different? Okay. Notice this is changed, but notice those 2 are interchanged, right? Okay. So what we did here, and this is the notation we can use, we got this one because we took R2 and we put it in R1. So we took row 2 and we put it up here in row 1. And we got this one here because we took row 1 and we put it in row 2. Okay? And R3 is just the same, unchanged. Okay, so that's no change to it. Okay, so let's think about the next one. How do I get from these to these? Okay, so notice this one's unchanged, right? So this is just row 2 and this is just row 3 over again. Okay, so those aren't changed at all. What are we doing with this to get this? Okay, notice we're multiplying it all by 2. So we're finding 2, or negative 2 actually, right? Because they're negatives. We're taking negative 2 times R1 and we're putting it in R1. Okay, so we're taking this row, multiplying everything by negative 2, and we're putting it here in row 1. Okay, next ones, how do I take this and get it to be this? Okay, so notice row 1's unchanged. Okay, so that's going to stay the same. R2 stay the same. Now R3, how do they get R3 here? Okay, so probably using this third element, right? So rows can be interchanged, as we did here. They may be multiplied by a number, right? So we multiplied everything by -2. And they can be changed by adding an element to a multiple of the corresponding other. Okay, so what can I do with any of these other ones and multiply them together and add together with this one to get this? Okay, so what if I would take -1 times R1, and then I add it to R3, and then put it into this R3 here. Okay, so let's see if it works. So I take -1 times 1 is -1, plus 1 is 0. Okay, try the next one. 3 times -1 is -3. -3 and -1 give you -4. 5 times -1 is -5. Minus 2 more is -7. -1 times 2 is -2. Plus 4 is +2. Okay, so that's how they get that row right there. Okay, so we can do these three things anytime we want to. And it's still the same equation. Okay, now echelon form. So day 1, we're going to talk about echelon form. And then day 2, we're going to talk about reduced row echelon form. Okay, basically echelon form is ones down the diagonal and zeros below the ones. So if it's say it's a 2 by 3 matrix, we would want ones here, ones on the main diagonal, and zeros below it. Okay, if it's a 3 by 3, we have ones on the diagonal and zeros below it. Okay, so that's what's meant by echelon form. Ones on the diagonal, zeros below the ones. Okay, then we're going to use these other numbers up here to solve. So if we think about this right here, okay, so let's think about how we're going to change them. Okay, so I want this top number to be a 1 here, right? So how can I get that to be a 1? Well, I can multiply it by 1/5, right? So I'm going to take row 1 and multiply it by 1/5. Okay, so if I multiply this by 1/5, I get 1x. Well, I should first change it into, before I even do that stuff, let's change it to the matrix form. So 5, 2, 1, 2, -1, 4. Okay, I like it in the augmented because then we can see the x, y versus the numbers. Okay, but anyway, so we're going to take 1/5 of row 1. Okay, so 1/5 of 5 would be 1. 1/5 of 2 would be 2/5. 1/5 of 1 would be 1/5. Okay, so we have our 1 there, which is what we want. Okay, now we want this one to be a 0 here, right? So how can I get this to be a 0? What I can do is I can take -2 times row 1 and then add it to row 2. So if I take -2 times this would be -2 plus 2 would be 0, right? Okay, so if I do that operation there, -2 times 2 times 1 is -2 plus 2 is 0. So actually this one, I'm just going to rewrite this one because we're not changing this one. So that gives me a 0 here, right? -2 times this plus that is 0. We'll go to the next one. -2 times row 1. -2 times this would be -4/5 plus -1 would be -9/5. And same thing here. -2 times this would be -2/5 plus 4 would be 18/5. And you can use decimals too if you prefer that over fractions. Okay, so now we have a 1 and a 0. Now we need to get the 1 right here yet. Okay, so how can I get this to be a 1? So I can put it up here. I can take and multiply it by its reciprocal. So I'm going to take all row 2 and multiply by the reciprocal of this. Will give me 1. Row 1's not going to change at all. Okay, so this times 0 is still 0. And this times this will make a 1. And that times 18 fifths makes negative 2. Okay? So basically, if we change this back into our system of equations, right? This is like a 1x. Oh, sorry, by the way, we have it in echelon form now, right? We have 1s and then 0s. Okay, so this is how we use it to solve. We basically have 1x plus 2/5 y is equal to 1/5. And we have y equals negative 2, right? So notice here, y equals negative 2 is already solved for. That's what this echelon form does. It solves for one of the variables. Then we can take that and plug it back in here. So you'd have x plus 2/5 times negative 2 is equal to 1/5. And you solve that and you get x equals 1. Okay? So this is just another method of how we can solve these systems of equations. Okay? Let's try another one. Okay, if we put it in, we have 1, negative 1, 5, negative 6, 3, 3, negative 1, 10, 1, 3, 2, 5. Okay, so there's our matrix. Okay, so we have a 1 here, so we're good there. Okay, so what's our next step? We want to try and get 1s on the diagonals and 0s everywhere else. Okay, so notice here, we first tried to get a 1 there. Our next step was try to get a 0 underneath it, and then we can work on the 1 next to it. Okay, so that's our goal here as well. So what are we going to do here with this? Okay, so we have a 1 here, so we're good. Let's try and get a 0 right here. Let's take negative 3 times our row 1 and add it to row 2. So that would make negative 3 times 1 is negative 3, plus 3 would be a 0 there then, which is what we want. Okay? So we're not changing row 1. Okay, so negative 3 times that is negative 3, plus 3 is 0. Negative 3 times negative 1 is 3, plus 3 is 6. 5 times negative 3 is negative 15, plus that would be negative 16. Negative 30, sorry, up here. 6 times, it'd be 18, plus 10, 28. Okay, so we have that 0 there now. Okay, next thing, I'm going to come up here with it. Okay, so let's take it and let's get the 0 here as well. So we'll keep getting the 1 and the 0 and the 0. By the way, you could do 2 steps at one time if you want to. I'm just doing it a step at a time here. So let's take and just add these two together. Well, the negative, right? Or it says we can add them, but let's take negative R1, right? We'll take the negative of this and add it to row 3. So row 1, we're not changing. Row 2, we're not changing right now. Okay, so negative of this plus that would be 0. Negative this would be 1, plus that would be 4. Negative 5 plus 2 is negative 3. Negative 6 would be 6, plus 5 is 11. Okay, so we have the 1 with the zeros underneath. So now let's try and get the 1 here. So how can we get the 1 here? The easiest thing to do would just be to multiply this all by 1/6, right? We'll find 1/6 of row 2. Okay, so row 1, not changing. Row 2, if I take a 1/6 of 0, it's still 0. A 1/6 of that makes 1. A 1/6 of that would be negative 16/6, which would be negative 8/3. And a 1/6 of this would be 28 over 6, which would be 14/3. We're not changing this one. right now. Okay, so we have our 1 there. Now let's try and get the 0 underneath it here. So we're going to take -4 times this and add it to this. So -4 times row 2 and add it to row 3. So -4 times 0 plus 0 is still 0. By the way, I'm keeping these all the same. Okay, second one, -4 times this be -4 plus 4 is 0. So I'm going to take that 0 there that I want. -4 times this -32 thirds minus 3 would be 23 thirds. Okay, -4 times this minus 11 be -23 thirds. Okay, and we're almost there. We just need to get this to be a 1 yet. Right? So I'm going to take and multiply it by just the reciprocal. I'm going to take 3/23 of row 3. I'm not doing anything to the top one or the second one. Okay, and 3/23 times 0 is 0. That times that is 1. And 3/23 would be -1 there. Okay. Okay, so we have our echelon form here now. So now we can solve. I know that z is equal to -1. Okay, so z is equal to -1. I know that y plus, well, minus -8 thirds times my z is equal to 14 thirds. Okay, and if I solve this, that'd be 8 thirds and subtract that over. I get y is equal to 2. If I take the top row, I know that x minus my y plus 5 times the z will equal -6. Okay, -5 and -7, add the 7 over, you get x equals 1. Okay, so that is the echelon form. Okay, the other method is reduced row echelon method. When we see reduced row echelon, that just means that we're going to solve it all right in the matrix. We don't have to do anything at the end. We want 1s on our diagonal and 0s not just below, but also above. Okay, then we'll have like z is equal to this number, y is equal to this number, and z is equal to that. X is equal to that number. X equals this, y equals this, and z equals that. Okay, so that's what reduced row echelon form looks like. Okay, so let's work at getting that done. So x, y, z equals 6. 2x minus 1y plus 1z equals 5. And 3x, 1y minus 2z equals 9. Okay, so there's my augmented matrix to start with. Okay. So what I'm going to work on first is getting it into the echelon form, which we did before, and then we're going to work at the zeros above it after that. Okay. So I'm going to do two things first. First, I want to get these two both to be zeros. So I'm going to multiply this by -2 and add it to here, and put it into row 2. So -2 times R1. I'm going to add that to R2. And I'm also going to do the same thing here for R3. So -3 times R1 and add it to R3. Okay, so keeping 1 the same. Okay, -2 times 1 is -2 plus 2 is 0. Negative 2 times 1 is negative 2, plus that is negative 3. Negative 2 plus 1 is negative 1. Negative 12 plus 5 is negative 7. Okay, and then down here, using this, negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times 1 is negative 3 plus 1 is negative 2. Negative 3 plus negative 2 is negative 5. And negative 18 plus 9 is negative 9. Okay, so I got my zeros here. Now I need to get ones here and here. So, yeah, I guess I wouldn't necessarily need to get one there, but I think it might make it a little easier. So I'm going to do negative 1/3 of R2 and negative 1/2 times R3. So leaving 1 the same. Multiply this by negative 1/3 would still be 0. Multiplied by negative 1/3 makes 1. By negative 1/3 makes 1/3. Negative 1/3 gives you 7/3. And by negative 1/2 makes 0. By negative 1/2 makes 1. Times negative 1/2 makes 5 halves and 9 halves. Okay. Now I want to get a 0 here, so I'm going to do negative R2 plus R3. Okay, so negative of this and add it to this. Okay, so that gives me the top row is still 1, 1, 1, 6, and the second row I'm not changing. Third row, I'm going to negative 1 plus 1 is 0. Negative 1/3 plus 5/3 makes 13/6. Same thing here. Negative 7/3 plus 9 halves is 13/6. Okay, so get this one here yet. I'm going to multiply by negative 6. Sorry, not negative, just 6 over 13th. One, 1, 1, 6. Okay, and that times that would be 1. That times that is 1. Okay, so I already know that z is equal and get a 0 up here. So I'm going to take negative 1/3 times R3 and add it to R2. So negative 1/3 times this plus that. So leave these the same. I'm sorry, I wouldn't delete this, it's the same. Okay, so if I take negative 1/3 times 0 is 0 plus 0 is still 0, etc. That's going to be the same thing as well. 0 plus 1 is 1 still. Okay. Negative 1/3 times 1 is negative 1/3 plus 1/3 is 0. Negative 1/3 plus 7/3 makes 2. Okay, so I have the zeros here. Now I need to get zeros up here yet. So I'm going to take negative R2 and add R1 to it. So when I do that, okay, negative R2, so negative 0 plus 1 is 1 still, and negative 1 plus 1 is 0, and negative 0 plus 1 is 1, and negative 2 plus 6 is 4. Okay, so I got the 0 there. Now I need to get the 0 here, then I'm done. So I'm going to do negative R3.
For number 8, I got undefined.
Okay, so I'm going to do negative R3 plus R1. Okay, so negative of this plus that would make 0 there then.
You're unmuted.
So I'm not changing the bottom, not changing the middle, but here I'm multiplying this. So 0, so negative 0 plus 1 is still 1, negative 0 plus 0 is still 0. Negative 1, so I gotta do it over here. Negative 1 plus 1 is 0. And negative 1 plus 4 is 3. Okay, so now I have it in reduced row echelon form. Okay, so I have zeros everywhere except for this main diagonal. So I can see that this is my x equals 3, my y equals 2, and my z equals 1. Okay, number 4, we'll start by making our automated matrix. 1, 2, 1, 30, 3, 2, 2, 56, 2, 3, 1, 44. Okay, so we'll get the echelon row, get this and this to be zeros first. So I'm going to take negative 3 times row 1 and add that to row 2. And negative 2 times row 1 and add that to row 3. Okay, so negative 3 times that, add it to this, gets 0 there. Negative 2 times this, add it to this, gives me 0 there. Okay, so that gives me, didn't do anything at the top. Okay, so negative 3 times 1 plus that is 0. Negative 3 times 2 is negative 6, plus 2 is negative 4. Negative 3 plus 2, negative 1. Negative 3 be negative 90, plus 56 is negative 34. Okay, down here, negative 2 and 2 gives 0. Negative 4 plus 3 is negative 1. Negative 2 and 1 is negative 1. Negative 60 plus 44 is negative 16. Okay. I'm going to get these to be 1s. So I'm going to do negative 1/4 of R2 and negative 1 of R3. Gives me 1, 2, 130. 0. That times that is 1. That times that is 1/4. That times that is 34/4. You can also put it as a decimal if you want to. Times negative here just makes 0, 1, 1, and positive 16. Okay, to get this to be a 0, I'm going to take negative R2 plus R3. And you really could do this different ways. This is just the way I'm doing it right now. So I'm not changing these other two yet. So negative this plus this is still 0. Negative 1 plus 1 is 0. Negative 1/4 plus that is 3/4. Negative of that plus that would be 15 halves or 7 halves, 7.5. Okay, you want that to be a 1, so I'm going to take 4/3 of R3. Gives me, didn't do anything to the top, or middle. Okay, it'd be still be 0 and 0. 4/3 times that gives you 1. 4/3 times that gives you 10. Okay, so we know now that z is equal to 10. Okay, now let's work backwards. Let's get a 0 here. So I'm going to take negative 1/4 of this number, of R3, and add it to R2. Okay. So that will give me, didn't do anything to the top or the bottom. Okay, so negative of this is 0, plus 0 is still 0. Negative 0 plus 1 is still 1. Okay, negative 1/4 times 1 is negative 1/4, plus 1 plus 1/4 is 0. Negative 1/4 times 10 plus 34/4 gives us 6. Okay, so I know that z, and I know my y here is 6, and I got to get 0 and 0 here. So I'm going to do this one here first, this 2 here. So I'm going to do negative 2 times this and add it to this. Okay, so I'm not changing this or this. So negative 2 times 0 is 0, plus 1 is still 1. Negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 0 is 0, plus 1 is 1. Negative 2 times 6 is negative 12, plus 30 is 18. The last thing I need is here, so I'm going to do negative this plus this. So negative R3 plus R1. So I'm not changing these two. So negative 0 plus 1 is 1, negative 0 plus 0 is still 0, negative 1 plus 1 is 0, negative 10 plus 18 is 8. So now I know that x is equal to 8, y is equal to 6, and z, whoops, there should be 1 there, z is equal to 10. Okay, that's the reduced row echelon form. I will also show you how to do this in Desmos here in a little bit too. For number 5, if you put this into the matrix form here, and if I take negative 2 of R1 and add it to R3, okay, notice that is how I get 0 here, right? Okay, and notice as I do that, these are all going to be zeros. I get this. And if you remember back when I had like we used elimination or substitution, I had 0, no x, y, no z, none of them there are equal to a number, it was no solution. It's the same way here too. So if you get something like this equal to a number, it's going to be no solution. And the other way we can look at it here is if I take my matrix, this isn't in your notes, I kind of add this to it later, I set this up and I do this, okay, and I get this in the bottom. Okay, so this says that, remember when this was true, it was like we had parallel lines, okay? I mean, not parallel lines, these were parallel lines. These were the same line, right? So there was an infinite number of solutions here with these. Same thing here too. This is going to be true for every x, y, and z, okay? So what we're going to do, what I'm going to encourage you to do then, is to get it in reduced row echelon form, which I'll show you how to do that in Desmos here in just a minute. So if you get it like this, okay, we have zeros across here, so z is just a z. My y, okay, if I think about this equation right here, it'd be like y minus 7/13 z is equal to 15/13. And if I add that 7z over, I get y is equal to 7/13 z plus 15/13. Same thing up here, my x is going to equal negative 2/13 z plus 44/13. Okay, and you can have that. It's kind of there's an infinite number of solutions to there, but it has to be those sort of numbers. Okay. Next, I'm going to show you on Desmos how to do this problem right here.
Okay, so to do this in Desmos, you're going to go to desmos.com. You're not going to go to the graphing calculator though. You're going to go down towards the bottom here, and you're going to see the matrix calculator. Okay, so right here, matrix calculator, and this is what the calculator looks like for matrices. Then we'll use this later in semester 2, next week. But anyway, we're going to create a new matrix. We have to tell us how many rows and columns there are. So in that particular problem, there were 3 rows and 4 columns. So here's our matrix, and we want to put those numbers in there. Okay, it was 2.1x, 0.5y, 1.7z equals 4.9. Negative 2x, 1.5y minus 1.7z, 3.1. And the last equation was 5.7x minus 4.6y plus 0.8z is equal to 9.3. Okay, now there's our matrix. It's called matrix A. Now this makes it really easy. We're going to do reduced row echelon form of matrix A. Boom, there it is. So we know that z is equal to this number, x, y is that number, and x is that number, and you can turn it to a fraction there too. So you can go back and forth, decimal or fraction. So you can see x, y, and z. Desmos makes it extremely easy, doesn't it? I will, though, as you're taking a quiz or test, I will expect you to show me the steps as to how do you get this reduced row echelon form, but you can definitely check your answers here.